Warmly welcome to the NF Wire Forum. My name is Christopher Folland and I am the Technical Manager Wire Drawing Lubricants at BECHEM. If you have specific questions for lubricants, please contact me on the given ways. Today I want to tell you a bit about lubricants for wire drawing in general and especially for fine wire drawing. Therefore, please take a look on my short agenda. First of all, I want to introduce you the different types of liquid lubricants. Some information about the requirements for fine wire drawing, what is necessary to be observed, and last but not least, a short excursion into the world of filtration. So let's start with the drawing lubricants. Which types are there and what are their characteristics? The first one would be drawing oils. They are typically used for aluminium, copper, alloys, and for form wires, as for example trolley wire. Oils have some benefits, as a very good lubricity and a flexible viscosity, but also some downsides. They have a quite poor cooling capacity and the filterability is weak. The next one are the emulsions. These are a mixture of water and oil, so therefore we have productivity for copper wires traditionally down to 0.1 millimeter, and nowadays also for aluminium in approximately the same sizes. Their benefits are a good cooling capacity and adjustable lubricity over the concentration and additivation. They are pretty well filterable, which is also driven by the concentration. A very high concentration leads to a little bit higher viscosity, and due to that, a less good filterability. And also due to aging of the emulsion and therefore the bigger droplet size, the filterability gets weaker with the aging. As already mentioned, the viscosity is slightly adjustable over the concentration. The last form would be the fully synthetics or solutions, which are one-phase water-based lubricants. These are used for fine wire production below 0.15 millimeters. They are used for copper and copper alloys, as well as covered wires, for example, tint wire. Their benefits are that they have excellent cooling capacity, perfect filterability, and the lubricity is also adjustable. And they are free of mineral oil and emulsifiers, and therefore they can't split, and tramp oil is simply floating on the top and can be sucked away. After this short introduction of the different types, let us talk about the requirements for the drawing process. The requirements on drawing lubricants are very diverse. They don't only have to lubricate and cool. They also need to keep the machine clean, carry fines to the filtration, protect the machine and drawn material from corrosion, and have to be compatible with further processing steps. Although the requirements on environmental and user-friendlyship are continuously increasing. And last but not least, it is requested that they should be cheap and easy to dispose. But these 2 points are not strictly driven by us. The requirements are also mainly driven by the dedicated process, which is going to be done. By that, we come to the following points. The selection of the right lubricant, which is driven by the drawn material, the final diameter and the subsequent processing, and also by the water quality. As the water quality is giving an impact on the emulsion characteristics or the solution characteristics. And the water is containing in the lubricant with 80% and higher. After we have talked about the different types and requirements, let us come to the monitoring and maintenance. What belongs to the maintenance? Let us have a look to my slide. Which role? So, the workplace, the drawing machine, periphery, the emulsion monitoring, and the evaluation of measured data and the caretaking of the necessary actions. Which role does the machine operator have in this? He should and has to observe the following parameters: the appearance of the system, the odor of the emulsion, the foam behavior, creation of residues, changes in the general cleanliness, and usual filter drag out or an unusual filter drag out. Because all these parameters show the operator that something is going wrong or maybe something is changing. Maybe a bacterial contamination, oil leakages, or whatsoever. If you have questions to that, let us discuss this face to face, please. What is to avoid? In general, the emulsion is no bin. In former times, it was quite usual to throw some dust into the emulsion and let it stay there. You shouldn't do that, especially if you are drawing fine wires. The cleanliness and the perfect cleaning properties of the emulsion or solution are very necessary. The addition of not committed additives or cleaners can also have a very bad impact on the drawing process. And the driving of the system with outside the nominal temperature for a longer time can also make problems. What do you have to take care of? As already mentioned, the nominal temperature range, which should be between 35 and 45 degrees Celsius as a big range, and ideally should be between 38 and 42 degrees Celsius. Adherence of advised measures and frequent control and documentation of essential emulsion data. What are the essential emulsion data? First of all, the concentration and the pH value, as already written on the previous slide. But also the conductivity, dissolved copper, and microbiological contamination. But they only need to be measured if needed. Corrosion protection tests on iron or copper should only be done if there is a suspected problem, as they are quite difficult to make and to evaluate. So the point 1 and 2, so the concentration and pH value should be measured ideally daily and at least twice a week. And they need to be documented and observed. As the conclusion out of this, a trouble-free wire production only is possible through a targeted emulsion maintenance and proper monitoring. Now let's take our short excursion into the world of filtration. How is the size of the filter calculated? How should be the tank size? And so on. So the dimensioning of the tank and filter. The tank size should be 10 times the flow rate per minute, minimum. So for 400 liters per minute, it must be 4,000 liter tank size. The filter size is not only calculatable on the tank size or the flow rate. Here also the filter fine, how fine is your filtration is the point, and how is the backflow system. You have a backflow by gravity, or is it a pumping system which is only pumping every 2 to 3 minutes or whatsoever? But please discuss this with your chosen filter producer. They have the higher knowledge on this. For the right filter material, the main point is the finer the merrier, especially for fine wire drawing. But it should be at least 100 grams per square meter. And you need to maintain your filter system. If it is not proper sealed, the emulsion will just flow beside and you have no filtration at all. Sizing of piping and pumps also should be observed and needs to be dedicated to your flow rate and everything. So let us take a short resume of what we have talked about. For the fine wire drawing, the following parameters are essential according to the lubricant. The right lubricant choice, the dedicated system design, optimized filtration, usage of a suitable water quality, a perfect coolant maintenance, and an observing by the operator. And if you have any questions, please do not hesitate to contact us.